Hello everybody, today's video is going to be on solving two-step inequalities. There's actually nothing new to learn, it's just a combination of all the stuff we've learned previously in this chapter as well as techniques from last chapter. Keep in mind this is the last section of the chapter, which of course means we have a test coming up. This is a short week and we have Monday off, so you can expect the test to be on Tuesday of next week. Luckily, it's only 4 sections to practice, and we'll have a day in class, at least a full day in class to do review. So have your questions ready. Anyway, let's move right on to some examples since there's not a lot of new stuff to learn here, if anything. So example 1, let's try to solve this inequality. -5 plus c over 3 is greater than -1. A lot of mistakes that I'm seeing from you guys involve trying to multiply this 3 first. You can do that if you want, but a lot of you forget to multiply this -5 by 3 as well. Remember, with multiplication and division, it has to happen to every piece. Every term is what they're called, right? With subtraction and addition, it just has to happen to each side, and so some of you are getting confused. The easiest thing to do here is to get rid of this -5 or this -5. We do that by adding 5 to both sides because -5 plus 5 is 0, and our goal was to get rid of it. So now we end up with c over 3, and it's positive because of this, is greater than, and -1 plus 5 is 4. Now we can get rid of this division by 3 by multiplying both sides by 3. And so after some Fruit Ninja work here, we end up with c is greater than 12. Notice the sign stayed the same every time because we did not multiply or divide by a negative number. Just to show you that it works, I'll show you the alternate technique here, because trying to do it, I'll show you that it does work with doing the multiplication first, as long as you do it correctly. If you want to do the multiplication first, you have to do it to every term. So everything has to be multiplied by 3. Everything. Okay? So now every term is being multiplied by 3. So I'll get -15. After we Fruit Ninja these 3's here, we get plus c. The inequality symbol does not change direction because we're multiplying by a positive number. Over here, 3 times -1 is -3. Now it looks simple enough, so we're going to add 15 because this is a negative or a -15. To get rid of it, we add 15. And as you can see, we end up with the same answer because -3 plus 15 is positive 12. So we end up with the same answer. It's just that most mistakes people make are here because they do the multiplication to just this term and this side, and they leave out this. You can catch your mistakes easily there by just plugging the answer back into the variable and seeing if you were correct. Now let's do some more examples. Lots and lots of examples. Let's try nope, let's do 1/5, positive 1/5 is greater than or equal to -1/3 a plus 1/2. Alright, so some people get scared of fractions. It's done the exact same way. One thing that you can think about here is -1/3 times a is the same as saying -1/3 times, let me write it this way, -1/3 times a/1. So if you get concerned about what to do in this case, just write it like 1/5 is greater than or equal to -a/3. So that might make it a lot easier for you. Remember, this is an a, not a 9. My a's have a little extra tail on them, I guess. Don't mess that up. that is an A. So yeah, if you make it look just like a fraction instead of a fraction and a letter, it might make it easier for you. When we get to here, again, you could multiply everything by 3 if you wanted first. I wouldn't recommend that. I would like to get rid of this 1/2 first, so we're going to subtract 1/2 minus 1/2 from both sides. 1/5 minus 1/2. Well, let's see what that is. 1/5 minus 1/2 is the same as saying 2/10 minus 5/10. So that's going to be -3. Actually, let me write that out one more step, just so you guys know what's happening. Remember, when I have a common denominator, I can just add or subtract the top. And so that's -3/10. So over on this left side, we have -3/10. And on the right side, we end up with -a over 3. Now I can multiply both sides by 3. Again, this is not a scary proposition. Just because there's a fraction over here, I just make my 3 a fraction. Real simple. Just put a 1 there. As we wanted, this fruit ninja over here. And now, let me bring this down a little bit. Okay. We have a -a here. This sign is still this way, and we have a -9 over 10. So that's a 9, that's an A. Now, some of you want to just leave it there because the variable is all alone, but I don't care what negative or the opposite of the variable is. I want to know what the variable is. So we do actually have to do one more step here. The trick to getting a variable to be positive is you can take the opposite of it. The easiest way to get the opposite of something is multiply by -1. There we go. Multiply by -1. As you know, multiplying by 1 doesn't change anything. But the fact that we're multiplying by -1 means we take the opposite. So -9/10 times -1 becomes +9/10. The sign has to change now because we multiply by a negative. And this formerly -a becomes a +a. So a is greater than or equal to 9/10. Also, I forgot to graph that last one, so we might as well do it on this one. If 0 was here and 1 was here, 9/10 would probably be somewhere around here, maybe even a little higher, but that's fine. A is greater than or equal to, you might want me to flip that around, so A is greater than or equal to 9/10. So we're going to shade to the right. It's going to be a closed circle because of this little equal sign here. And that is it. Let's do another example. Some of you guys get concerned about decimals. It doesn't actually change the way you do it. You do have to know the rules for multiplying and adding and subtracting decimals. I'm going to change this letter here. I was going to use an S, but it looks too much like a 5, so let's make it an X, shall we? 0.75x plus 5.7 is less than or equal to 1 point. Nope, not 1 point, just actual 15. Okay, first step. You could, if you wanted, divide by 0.75, but keep in mind, if you do that, everything has to be divided by 0.75, even this nasty decimal. Okay, so right off the bat, I don't really want to do that. So I'm going to start by subtracting 5.7, which is what I recommend. So we'll end up with 0.75x is less than or equal to, well, 15 minus 5 is 10, and then minus 0.7, we're going to end up with 9.3. Now we're going to divide by 0.75, so it's kind of unavoidable that we have a decimal division here. So I'll just go off to the side here. We're going to have 930 divided by 75. Let's see what happens. I'll bet it won't be too bad. 75 goes into 93 once. We'll do some carrying here. So 5, we get 18 Bring down this 0. 75 goes into 180 twice, and that's 150. We get 30. We bring down this 0. And 75 goes into 304 times. Don't forget that decimal, 12.4. And that goes in evenly, so I can stop. X is less than or equal to 12.4. That wasn't so bad. A couple of multiplications and we're done. If I want to graph that, which you probably have to know how to do, so you might as well practice. We'll say 11 is right here, and 12 is right here, and 13 is right here. 12.4 is almost in the middle between 12 and 13, just a little to the left of center. And we are less than or equal to, so we're shading this direction and the arrow to show that forever and ever it can be less than. Alright, let's try one more example, then we can be done with the video. Do negative 1.7 minus y over 1.5 is greater than 4.9. Okay, I'm trying to pick ones that kind of look nasty just to show you that it's no big deal to add and subtract decimals and all that. Again, we can start by multiplying by 1.5. So we could start up by multiplying by 1.5 if we want, but if you do that, you're going to have to multiply every single thing, this, that, and that by 1.5. So I'm going to do the easiest thing first, which is going to add 1.7 to both sides because that is currently the opposite, or a negative 1.7, or a subtraction of. So those go away, leaving us with, don't forget this, negative y over 1.5 is greater than 4.9, 5.9, 6.6, looks like. Now, remember the subtraction sign in a fraction is a negative sign. The subtraction, it's all the same thing, and you can write it in several ways. So you could write it like y over negative 1.5. You could write it as negative y over 1.5. You could write it as negative and the whole fraction. Okay. You cannot write a negative on top and negative on bottom because that would be positive. So in the interest of what we're trying to do here, which is get y by itself, let's just have that that negative symbol on the bottom. That works just as good, and we'll speed things up by one step for us. So I'm now going to multiply both sides by, well, negative 1.5. We'll take care of the negative and the 1.5 at the same time. That will fruit ninja this, leaving us with y. It flips this because we're multiplying by a negative number. And then we just have to do some decimal multiplication. No big deal. 6 times 5 is 30. 30 again with a 3. Placeholder 6, 6, 0, 9, 9 with 2 decimals, 9.9. What I like to do is estimate, see if that makes sense. 6 times 1 is 6. So 1.5, 9 makes a lot of sense. We're going to graph that. If this was 9 and this was 10, 9.9 should be somewhere pretty close to 10. It's not a closed circle though, so I'm going to take that away. It's open and it is less than, so we just shade this direction and we are done. See ya.